Section 5.3 might be one of the easiest sections in the entire course. It's called inverse functions. And the first thing to know is if you have two functions that are inverse functions, I'll call them f and g. If you happen to know that the point AB is on the first function, f of x, and g is the inverse function, then g has to contain the point b comma a. You should be able to remember that from algebra, that when you take inverses, you switch the x and the y around and you solve for y. That's one way to get it. You also have symmetry around the line y equals x. So it would make sense that if AB is on one graph, BA would be on the other. The thing that you haven't learned yet about inverses that will be new is that the slopes between point AB on one graph and BA on the other are reciprocals of each other. Now notice that I said reciprocals and not opposite reciprocals. Opposite reciprocals is from geometry when you're doing perpendicular slopes. These are simply reciprocals. And you'll see this play out as we do some examples. Okay, I made two functions. The red function is f of x, and the blue function is the inverse. Again, that f negative 1, that's a symbol for inverse. It's not the greatest symbol ever made. In fact, it's a symbol for reciprocal as well, which I hate, the fact that they're the same. But hey, like I said, I'm just the messenger. These two functions actually are inverses of each other. I made sure. And the 0.29 is on the red graph, and the 0.92 is on the blue graph. You can always verify if you want, if you don't trust me, but they are. I'm going to show you that the slopes are reciprocals. So let's start over here with f of x in red. Slope, of course, in our class, indicates we need to take a derivative. And the derivative here will be 10x. If you put the 2 in, the slope of the tan line is going to be 20. Okay, over here on the blue side, this is going to be 1/5 x plus 11/5 to the half power. I'm just going to rewrite it before I take a derivative. And the derivative, I'm not even sure how to notate this. The inverse derivative, that's weird looking. It's going to be 1/2 out in front, stuff to the negative half, times a chain rule of 1/5. All right, if I rewrite that, that's going to be 1/10. All right, we got 1/10. And then the rest of this is a square root in the denominator. Okay, in goes the x, which in this case is a 9. So you get 9/5 plus 11/5. That's 20/5. 20/5, I like to call that 4. So this whole thing is a 4, but it's inside a square root, so it's radical 4, which means it's a 2. And check it out. We got 1/20th. And as promised, the slopes are reciprocals. I'm going to take you back in time to your earlier math classes. F of x is 1/4 x to the third minus 3. That's that red graph that you see pictured. The inverse function, remember from either Algebra 2 or Pre-Calc or both, what you have to do is you have to change the x's and y's around. So remember that f of x is the same thing as y. So if you want to find the inverse function, you switch the x and the y. Everything else freezes, including the third power. It just freezes there and becomes part of the y. Then you get y by itself. So you'd add 3 to both sides. Multiply both sides by 4. And finally, last but not least, cube root both sides. And then y will just change into the inverse function notation. And you can see if you graph that on a graphing calculator, you'll get the blue graph, which is what I did. And notice that inverse functions are symmetrical around the line y equals x, that dotted diagonal line that goes through the origin. And sure enough, the points that you see, for instance, this point up here is -1, 2. If you flip it around, 2, -1 should be on the other one, and sure enough it is. Same thing with the 0, -3, and the -3, 0, as well as the -2, -5, and the -5, -2. But again, you knew that from earlier. What you didn't know from earlier is the slopes of the tan lines. Check this out. Going past 2, -1 on here, that's a pretty steep slope. Going past its mirror image, -1, 2, not so steep. They are reciprocals. But they're not opposite reciprocals. Both of those green slopes are positive. They're just flipped upside down. Even when the slope is 0, like at this point of inflection, if you take the reciprocal of 0, you get a vertical tangent, undefined slope. So that kind of makes sense. I just wanted to show you that visually. Okay, back to another example. Number 2, if g of x, which does not appear in the chart, is the inverse function of f of x, write an equation for the tangent line of g of x at x equals -1. All right, well, tan line, that tells me I'm going to be in point slope form. So I'm going to come down here and just write my answer. And again, I also know that x is -1, so that's going to be x plus 1. But the thing about it is, this is g. I want the tan line to g of x, and there's no g of x in the chart. G and f are inverses, so here's what I need to do. I want to know what's up with g of x. It goes through the point -1 something, but I don't know what the something is. But if f is its inverse, then f has to end with a -1. And these missing values will be the same. Well, I have a chart for f of x, so all I have to do is just go there and pick the one I need. The problem is, don't pick the wrong one, which I just did. It says x is -1, sure, but that's for g of x. You need to be down here. F of x goes through the point 7, -1, according to the chart. So therefore, g of x is going to go through the point -1, 7. That gives me my y-coordinate for the final answer. Now I just have to figure out slope. Well, again, slope is derivative. We have a chart. The derivative of f of x is 4/11. And moments ago, we learned that if you have points that are mirror images of each other with inverse functions, the slopes at those places are simply going to be reciprocals. Again, not opposite reciprocals, just reciprocals. The 11/4 goes in, and that's your correct answer to number 2. Again, same thing. This time the other function we'll call h of x. It's the inverse of f. And we want a tan line to the graph of h of x at x equals 3. This should be a little easier. Same chart and everything. Okay, again, I want the tan line for h of x, and h of x starts with a 3. That means that f of x, being the inverse function, is going to end with a 3. Okay, again, don't go here. Don't be tricked. We want to go up here. F of x has a y-coordinate of 3, so that's going to be -4, 3. So therefore, h of x will be 3, -4. Those will be points along those graphs. All right, and then finally, let's grab some slopes while we're here with the table. The slope, the derivative of f of x, which is the tangent slope, is 1/2 at the point -4, 3. That means that the inverse graph is going to have a slope of 2 at 3, -4. All right, we can write the tan line now in point slope form very easily. So here we go. That's all there is to it. Last but not least, here's number 4. And it's a little bit more interesting because we have a composite function to deal with. J and H are inverses of each other. And we need to write an equation for the tan line to the graph of J when it goes through x equals 2. Okay, H and J are the inverses. Let's go ahead and write this out.
All right, we want the tan line to j when j goes through 2 something. Well, if h and j are inverses, that means that h has to end with a 2. And the slopes have to be reciprocals. We know that for sure. All right, so we have some figuring out to do. Let's go ahead and take the equation that we started with and work with it by plugging a 2 in for h of x. I'll show you what I mean. H of x. I don't know what x is, but I know that y, or in this case, h of x, is this 2 right here. So we have 2 equals g of f of x plus 1. We'll subtract 1 from both sides. So we have g of something equals 1. Let's go to the chart. G of something is 1. You can see it right here. There's the 1. That's going to be g of 0. So g of 0 is equal to 1. So f of x must be 0. So what's x? Well, let's see. Here's f of x, 0. Okay, x is 4. So we've determined that x is 4, which means that h goes through the point 4, 2. And so therefore the inverse j must go through the point 2, 4. All right, so we're getting closer. All right, to find the slopes, let's talk some derivatives. Again, we're going to take this h of x equation and take its derivative, so that'll be h prime of x. This is going to involve some chain rules here. G of f of x, the derivative of g of something would be g prime of something. And the something is the embedded f of x there. But is there a chain rule? Does the stuff inside the parentheses have its own derivative? Well, of course it does. The derivative of f of x is f prime of x. All right, now remember that we're at 4 with h. We want h prime of 4, so we need to turn all the x's into 4s. There, that's pretty easy. And now let's just see if we can figure out what's going on. I'll start at the end here. A little less going on there. F prime of 4 is going to be this 3 right here. F of 4, which is inside the parentheses, f of 4 is 0. So let me replace this with a 0. And g prime of 0 is 7 right here. So this whole thing is a 7, meaning that when you hit the point 4, 2, the slope or derivative of the red h of x function is 21. Meaning that if h and j are inverses, j is going to have a reciprocal slope of 1/21 at the point 2, 4. All right, we're supposed to write the equation for the tan line for j of x. Here it is. It's going to be y minus 4, at 4 right there, equals 1/21. Notice I'm taking the reciprocal, not the opposite reciprocal. It's not perpendicular. X minus 2. Here's the 2. Again, you can put this in slope-intercept form if you want to, but it's completely unnecessary. Point-slope form is fabulous and easier and safer and correct. And that's it for number 4. That's it for section 5. C, inverse functions. Good job. Catch you later.